There are n numbers a1, a2, a3 all the way till an, each of them being plus 1 or minus 1. If it is known that a1, a2 plus a2, a3 plus a3, a4 all the way till an minus 1 an plus an a1 is equal to 0. Remember, each of these products has to be either plus 1 or minus 1. Okay? Adding plus 1 and minus 1 and finally getting to 0, there should be equal number of plus 1s and minus 1, or there should be an even number of terms. And so let's talk about having two terms. We had 1 and minus 1. Minus 1 and minus 1 won't work. Then the product will be 1 into minus 1 plus minus 1 into 1. The final expression, that will be minus 2. That doesn't work. Say there are 4 terms. We have 1, minus 1, 1, minus 1, minus 1, minus 1, minus 1, minus, that won't work. 1, minus 1, minus 1, 1. Maybe that might work. This expression will be minus 1, plus 1, minus 1, plus 1 equal to 0. N equal to 4, this works out really well. N equal to 2, this does not work. N is a multiple of 2 but not a multiple of 4, it doesn't work. Multiple of 3 doesn't work. N can be any multiple of 4. The only possible value of n is 4. The 2 possibilities. Okay, let's think about this. Let's construct it. Let's see if we can construct it for 6. 1, minus 1, minus 1, 1, 1, minus 1. Does it work? Product is minus 1, 1, minus 1, 1, minus 1, minus 1. 1, 2, 3, 4, 5, 6. There are 3, 4 minus 1. So this doesn't work. Why is that happening? 1, minus 1, minus 1. So there are 2 minus 1s here and 2 minus 1s there. This doesn't work. With 6 numbers, n equal to 6 does not work. See if we can do better than that. N equal to 6. Let's see. Minus 1, minus 1, minus 1, 1, 1. This product is minus 1. This is 1. This is 1. This product is minus 1. How many ever times 1 and minus 1 are adjacent to each other? Or only 1 and minus 1 are there adjacent to each other? This can work. So there should be a minus 1 and a 1 next to each other. That many times we'll have a minus 1. That many adjacencies we should have. And so minus 1 and minus 1 should be next to each other half the times. So 6 and 3 times they should be next to each other. Here they are next to each other. Here they are next to each other. Here and here. So like we're arranging the numbers around a circle. Putting 1, minus 1, 1, minus 1, 1 around the circle because you're doing an and a1 as well. And so like we're putting 1, minus 1, 1, minus 1, minus 1, 1. Some combination. 1 into minus 1, minus 1. Another minus 1. Another minus 1. 1, minus 1. 1, minus 1, minus 1. This product is minus 1. This product is minus 1. This product is minus 1. This is plus 1. This is minus 1. This is plus 1. So with 6, it seems like it's not possible. That there's something happening here, some pattern that we still have not figured out. So we need to have minus 1s and 1s around the circle. Such that the minus 1s and 1s are adjacent to each other half the times. 3 times exactly. So here 1 and minus 1 are adjacent to each other. Here minus 1 and 1 are adjacent to each other. Here minus 1 and 1 are adjacent to each other. And here minus 1. So they're adjacent to each other either 4 times or 2 times. We're running into trouble. And so let's see if with 8 it is possible. If 8 it is possible, then we are through. And so 1, 2, 3, 4, 5, 6, 7, 8. Start with 1. Doesn't matter. Minus 1, minus 1, 1, minus 1, minus 1, 1, 1. This product is 1, this product is 1. Minus 1, 1, minus 1, minus 1, 1, minus 1. So how many products are minus 1? This is minus 1. This is minus 1. This is minus 1. This is minus 1. 4 minus 1s and 4 plus 1s. Minus 4 plus 4. It is indeed possible. With 6 it is not possible. With 8 it is possible. N can be. So these two we've already eliminated. 8 it is possible, so this is the answer choice. Why it is not possible for an odd multiple of 2, that's something we have not figured out yet. Those of you who are going through this, please figure it out and comment and reach out to us and say, oh, this is why it didn't work.